Hello, everyone. Good morning, good afternoon, and good evening, depending on which part of the globe you are joining us from. Welcome to this new episode of AWS on Air, and we are in the third week of reInvent 2020. I'm Suman Devnath, Principal Developer Advocate from AWS, and I'm delighted to have Guy Edrich, Principal Product Manager, Health AI at AWS. Hey, Guy, thanks for joining us. Welcome to the show.
Thank you. It's great to be on.
Absolutely. So last week, Swami announced, bunch of new services and features and capabilities in our machine learning stack and offerings. And Amazon HealthLake is one of our newest member in our AI service stack. So before we go deep into the service and its offering, can you just give us a brief overview of Amazon HealthLake and just explain a little bit about what problem it solves?
Yeah, no, that'd be great. So we launched Amazon HealthLake. It's a fully managed HIPAA eligible service. So in healthcare, that's really important. And what it does is it essentially allows healthcare and life science customers to aggregate all of their disparate health information from across various silos or formats into a centralized AWS data lake. So if you think about all the ambulatory or doctor's offices, hospitals, or clinical trials or labs, there's a lot of healthcare data out there and it's continuing to grow. And as it comes in different formats, we start to pull it together, and then Amazon HealthLake is a service that allows to actually take that data and put it into a centralized, normalized format. So then healthcare workers can start, or even researchers or partners can start working with the data in a consistent way.
Excellent. So basically, all we need is the data, and it can come from various sources, and we keep it in a data lake, and then from there, Amazon Health Lake, kicks in. So talking about different use cases. What are the new use cases that it enables for our customers to make use of this information, to make some, strategic or useful, business decisions?
Yeah. So one of the examples, so when the data comes in, it doesn't always come in a simple format. And so if you're going in and you have a doctor's visit or visiting someone, they're also taking notes. When they're taking notes, so they're clicking fields, but they're also taking notes. When those notes are coming in, they're coming in unstructured. So in that, there's a lot of information. And so what Amazon HealthLake does is it works in a format called FHIR. For those of you, it's called Fast Healthcare Interoperability Resource. It's an open protocol that a lot of the healthcare industry is moving towards. They're not there yet, but some people are. And so it uses an open kind of language that all healthcare people are using to transmit data. And so as that data comes in with the structured data, there's unstructured data. And so we extract that data. So that could be like medication, could be notes. The doctor, you could tell a doctor about there's a previous test, but he doesn't have that information. The clinical information will be in there. We'll extract that, we'll structure it. So we have specialized machine learning models that'll go through and structure that data and put it in a format and then append it. So essentially what you start getting is a holistic view of all the patient data. So myself as a patient going in, they'd also, if I didn't get data from my, another specialist I visited, they'd actually have a view of all my data now because they pull it out of the notes that the doctor took. And so from that point, the doctor has a complete view of you and they can get all the information they need. Some examples of where you're going to see this is when they're looking at an individual patient and you're trying to get that specialist information, but also aggregation. So if you look at a population of patients, so you're trying to look at a large part of patients and you're trying to look for different symptoms and conditions and medications, you can start aggregating that data. And you can also find out which patients, have stopped taking a certain medication. So it gives you a population view. It also can be used in clinical scenarios, so looking for different clinical conditions. And then it can be used for things like looking at different, risk models for patients. So in the US, we have a risk model of insurance. And within that, they're trying to find out what are different programs they can bring to patients to help them manage through either conditions they have or move them to a better care path. So these are just some of the kind of the high level examples that we're seeing.
Excellent. So I guess there are a lot going here, and the Amazon Health Lake is kind of removes all the heavy lifting, right, for our customers. So you spoke about different types of data that it supports, and when we talk about any healthcare industry, and we talk about any information for our patients, it could be of any format, right? So it could be plain text in the form of clinical notes, or lab reports in the form of PDFs, even medical images, ECGs, audio, etc. So can you just give us an overview of the whole process, how it looks like from start to end?
Yeah, perfect. So yeah, when you look at the data coming in, you can take, for a single patient, they can have medical image, they can have a lab test, they can have a patient visit, they can be part of a clinical trial. They're all different disparate systems, and all that data that's coming in has really important context, and it has context and sequence. So when it comes in like a medication or a different allergy or things along those lines, those are the things that you want to start connecting together and put in a chronological view. It can take weeks or months for people to go through it. In some examples, just extracting and normalizing that data that comes in can take up to, I think Mass General had a public example of 3 hours for a basic patient and up to 8 hours, right, when they're going after more data elements. And then just imagine if you aggregate that with a population of patients. So really our goal is with Amazon HealthLake is really to look at the data coming in, the interoperability data, and connect it with machine learning, because there's a lot of data customers have, and they want to use machine learning to start extracting and normalizing that data, so then they can find deeper insights.
Right. So I guess this is one of the common problem across machine learning. It's not a problem, but it's a challenge for any machine learning engineer or any organization who wants to leverage, or integrate machine learning or AI intelligence in their application, is to do feature engineering or data extraction and clean the data. And that is where half of the time or more than that goes in, and not every customers can afford to do so because of different skill sets that is needed, and also data are scattered across different silos, right? And Health Lake it can help us doing all of that under the hood, where you just throw the data and it can do that. So now you talked about a lot of things, and it seems like it can cater a wide variety of use cases, and can also generate new use cases or business cases that one can get out of it. So why don't you just show us how to get started for any of our new customers or any new developer?
Yep, sounds good. And so I've got a couple slides I'm just going to show real quick. And what I'll do is I'll walk through what's important here to show. I'm just going to walk through the statement, and then we'll go into how it works. But we kind of covered all the different data coming in. What's important to note is the structured data for some commonly used algorithms, such as chance of, risk of heart disease. They use 30 data points. But when you look at all the different data points that you can pull out of, including all the unstructured notes, per patient, it could be up to 300,000 data points. So going to your earlier point, the number of machine learning and capabilities really can start to just grow exponentially. And so I think just another thing, because I kept talking about this structured data, when you look at, these are just an example of a couple different sentences, right? This would be unstructured notes a doctor would type in. And so if you look at these 4 sentences, there's a lot of clinical data in there. And so as Amazon HealthLake, we'll go through and extract all the different data elements out of there. And so it shows examples of diabetes, and then I'll give it structured. So it's a JSON object on the far right. It'll be appended to the original data, so it never changes, keeps data integrity there, but allows you to get a view of all the data about a patient. And so just to give a quick visual of it, right? So the far left, you'll see this is the structured data. And then when you start extracting all of this data, when you start using machine learning models through APIs, and I'll show that in the next, that's all the data that you have access to.
Yaki, so one small thing is, can you just share your slides, I guess?
Oh, I have to share my slides here.
Yeah.
All right.
Perfect.
Okay. So sorry to repeat again, but I'm going to jump
That's
into
okay.
how it works. I think this is the one interesting slide to go through. This is the example that I was talking about the 4 sentences. But if you can see in these 4 sentences, it'll extract a lot of clinical data, and this will be a structured object on the far right, so your JSON object. So if you think all the data coming to you, you're no longer going through and trying to normalize it. It's all normalized and organized. It gives you an increased amount of data points, so you're starting to create different models with machine learning. This shows an example, just a nice visual of the structured versus the unstructured data. So you can see when you start looking at all of a patient data, this is one patient with an encounter. You'll see it on the far right. And then I think this is, to simplify it all, this is Amazon HealthLake. It's a set of APIs. It'll connect to multiple systems. There's 3 basic APIs all in the FHIR format. It'll structure all the data. So it'll go through all the data, it'll structure it and put it in this FHIR v4 format. It's an open standard format, nothing proprietary about it. It will run its specialized machine learning models, and then they'll all be accessible from search, read, and export API. This allows the service to expand and contrast depending on your usage. And so as a customer, you can really start focusing more on the machine learning, analytics, and third-party applications. And that's what we see people doing today.
Right. Excellent. So now that we learned some of the basics of the Health Lake and how it works, and what is the building block, and what are the prerequisite that the customer should have, like what kind of data that we support, and how to put that data to, or the provide the data to Amazon Health Lake. Would you like to show us a demo? I know that you have prepared one, so why don't you just show us in the console?
Yeah, that'd be great. So let's switch over to that. So let me just share again. And here we go. And tell me once you can see that.
Yes, perfect.
All right, I'm going to get it right this time. So this is just an example of Amazon HealthLake. So this is the product page you log into. And so as you log into it, you click on data source. So one of the first things that you're going to create is your own data store. This would be a customer-owned data store. And so in this example, as you're going through, you just go in, you type the name of it. It would be in the FHIR format, and then you have the ability to preload. So to get customers started, we have Cynthia Data, which is an open source synthetic data. So it's synthetically created data that maps to medical examples. So just allowing customers to get comfortable with it. And so you'll go through that. And then you have the ability to go into any of your data stores. So in this example, there's multiple data stores I've created. And you would just click on that. So this would be one of my data stores. And then I go in and start running these queries. So when I say these queries, these are the FHIR queries, those 3 points that I went through before earlier on that one diagram that showed kind of a can in the middle. And so these allow you to start querying your data, which is your read, create, read, update, delete. So in this example, we're going through and you'll type a FHIR resource. And for those not familiar, FHIR resource, think of it almost like a data table, but essentially it's where you're going to have all the information about a patient. And so you go through, and then within the FHIR format, you go through and you enter an ID. And so here I'm copying across an ID, and you extract it. And this will actually return back a response of the body, so you can get all the information. So pretty straightforward. Similarly, you can go in through all of these, and behind the console, there's all APIs, but the console is designed just to make it easy to get comfortable in running. This is a create. So this allows you to go in, and in this example, I'll go through, I'm going to create a new patient. So this is how someone would add a new patient. So this is like an encounter. This is like if I went to the doctor's office. And so the assigner's Acme Health, and it shows it's successful. When it creates it, it gives me an ID. And then I'm just going to show you how you can quickly read that ID and show you that it actually worked. So I'll update that. So pretty straightforward. The goal is that your index, as your patient data is coming in, it's constantly and continuously being indexed and structured, making it really easy to import the data and then make it really easy to actually start exporting and working with that data. So all that effort that's taken to kind of coordinate and put that, normalize that data, Amazon HealthLake starts doing that automatically. In this example here, I'm just showing a search. Well, not yet, showing a delete, but I'm about to move to search. And what's important about search is when you go and you select the different resource type, in the parameter list, it'll auto default to whatever the fields are within that resource. So in this example, you'll see patient, you can see active, address, name. And so we'll go into document reference. And for those familiar, this is typically where all that unstructured data comes in. So the notes, annotations, that would come in. And so in that, what you're seeing is we're auto defaulting, and this is where we're adding, right? So I said we added to that open standard of FHIR. This is where we're adding that unstructured data. So these are all the different elements that we're showing up top. And in this example, we'll go through and we'll search the entity text, and we'll type in hypertension. So what's important to note is hypertension was buried in that text that I showed you earlier. So patient had hypertension. You may not find it if it was in structured text, but now that we've structured everything and normalized all the data, as you search through, you can see that we found it. I'll also show you that just in a quick example of the type of data that you're going to get in. So all of this will be structured for you. There'll also be the ICD-10 code. So we do a concept of ontologies, and ontologies are essentially codes. So if there's a code for that, for hypertension, which I believe is IC10, you'll actually get that code too. And that becomes important because not everyone memorizes the codes. Some people do because they have to because their job, but it's a lot easier when you start doing analytics and all sorts of different use cases. So that's it. It's pretty straightforward. It's part of the design of the service. And so essentially we're really looking at pulling it all together, auto scaling for customers, talking in the language they have, and really trying to unlock that data that they have today and put it in a format that they can then start applying, larger clinical outcomes towards, like population health or clinical trials or different variety of different use cases.
Excellent. So, as I was watching this, I can realize that, there's a lot going on in the back end, right? There are a lot of, sophisticated NLP algorithm going around. There are a lot of pre-trained model that we have. And, our customers can just leverage that. They don't have to, worry about all of that is needed to come to the state, right? And a few of the, stuff that you shown, those are pretty interesting. And in fact, these can even forecast or give a doctor, if I just think of that use case, they can also see that, okay, this particular patient is going to have a heart attack in a probabilistic fashion, right? That, I mean, it can give some information in those predictions, like. So this is super useful, and healthcare is very, very critical for most of us and most of the companies around, right? Starting from insurance or even hospitals or clinical research companies, etc. Right. So I guess that this will surely unleash a lot of new use cases. One small thing is you talked about scale a little bit, but can you just brief our viewers about the scale and pricing about HealthLake?
Yep. So yeah, so part of the design is it's a set of APIs. It's going to scale both on data, so the amount of data you go in, the amount of queries. So you could have a lot of systems pushing you data, and you could also be extracting data, and then you could also be transforming data a lot. And so those are also the three dimensions of pricing. So there's kind of an entry level where you set up, but it really scales on data, number of queries, and the amount of data that gets transformed. And what's nice about that is you're expanding and contrasting depending on your demand. And if you're in healthcare, right, there's seasonality spikes of flus. There's a variety of different events that will happen where if you're managing it yourself, it's very hard to do. Versus you want a system that's expanding and contrasting based on your needs.
Right. Yeah. So I think scale is very very important. I mean, just like any other service that we have, and when we talk about our patient data or talk about healthcare, we have a ton of data. Even if I just consider one patient, we have tons of data, and that also in different format as you just mentioned. So obviously, scale is one of the a topmost priority that any of our customer would look for. All right. So now that we covered, most of the features and the advantages and new use cases, the last thing that I would like to ask you is about a few of the top use cases or you are seeing for our customers, and kind of a reference that our viewers can learn from.
Yeah. So some of the top use cases that we're seeing, and we've got a lot of examples of, are around population health. And so that's where people are looking in aggregate. And so if you look at an individual patient, you want all the data about them. And then when you get all that data about your patient, you want to start comparing it to peers. And so if you get all the data about the peers, then you can start informing really what's a better either care path or care plan for that population of patients. And so we're seeing that, and that's, we're in a unique time now where population health is really important. And you're looking at, trials going on, but you're also looking on just basic, right? There's a lot of things that are just happening with people today, and how do you get better care paths for them? So population health seems to be kind of the strongest demand that we see right now. And I think it's really unlocked that we're starting to provide getting all that data available for a patient immediately really starts enabling that comparison, and then those little cohorts start to expand. And that's really what it is if you can get all the data there and start predicting prior to a patient, right? If you have inclinations to move them to a better care plan, you're now actually treating them before they actually have a problem because you have more data about them, and less reactive because you have a subset of data and you're just seeing how they progress. And so that's really exciting. There's also some different um, initiatives going on. There's one in the US, and that's starting to drive a little bit more demand where people are starting to say, if we can start exchanging all this data in the FHIR format, so we've all kind of agreed, this is a simple format, that also gives everyone a common language. So it's really clinical operability and machine learning, really with population health. Now, there's a lot of other examples, so, but that's the one that I see kind of the bubbling up right now.
Excellent. Yeah. So I guess this fire industry standard format is very, very important because that is, kind of the standard across the industry, and that helps to, move the data from on-premise securely on the cloud as well. So that's always good to adhere to, that we are adhering to, that standard. So that's all I guess that we have. And one last thing is, I assume that this is in preview, and I'm very sure that we are going to take lots of feedback. And I know that we got a very good traction from the customers since it's launched last week. But do you have any last call out for our viewers?
Yeah, I think it's exciting time. The focus is really on bringing machine learning to help us with the data. Machine learning does really well with the data, so we're looking forward in preview. Preview is part of really evolving and making sure this is a new space and really setting a sound foundation. So excited to have more people in preview and continue to work and follow up as we move towards GA.
Sure. Thank you so much. Thank you so much, Guy, for all of your time and sharing insights. And I would strongly encourage everyone to go over the breakout session which Guy had on this topic at reInvent. And please explore the blog post that we have posted on this, as well as just sign up for the preview and get started with some hands-on, and do share your feedback, because that is the most important thing for us. So thank you so much everyone for joining us. Please stay tuned. We'll be back in a couple of minutes with another new announcement. Till then, enjoy the reInvent and have a wonderful day ahead. Bye-bye.
Thank you all. Bye-bye.